Now we're going to talk about a specific kind of function that we're calling a one-to-one function. The definition of a one-to-one function is that originally it is a function, but when we find its inverse, the inverse is also a function. So let's let the function f be the relationship between the people on the left and then the cars on the right, which will be the range. When we go from one area to another, the area that we travel from is the domain, and the area that we travel to is the range. So with this relation, we say, yeah, that's a function because each of the domain elements only goes to one y element. Now notice both John and Andy go to the Pontiac, but that's okay in a function. It's okay for two domain elements to go to the same range. We just can't have one domain element going to two different ranges. And then Joe goes to the Honda. So we say that f is, yes, a function. Now, the question is it a one-to-one function? So let's consider what would happen if we switch the domain and the range, or switch the x and y values. Let's call f inverse the function or the situation where we're switching. So now we're going to let the cars be the domain and the people be the range. And if that's the case, then we're going from the cars to the people, right? So we're mapping from the Pontiac to Andy, and we see actually the Pontiac goes to two different range elements. So this, which is now part of the domain, is going to two different range elements, and so we would say f inverse is not a function, and if the inverse is not a function, we would say then, therefore, the original was not one-to-one. Now let's look at the next example. So here we have another relation, and we are wanting to determine whether or not it's a function and whether it's one-to-one. So first of all, we'll let the original collection of ordered pairs be f, and we see that 1 only goes to 5, 2 only goes to 8, 3 only goes to 11, 4 only goes to 14. So let's say yes, f is a function. Let's then determine what the inverse function is. We get the inverse by switching each of those x and y values. So we say the inverse relationship is going to be 5 goes to 1, switch the x's and the y's, 11 goes to 3, 14 goes to 4. So the question is f inverse a function? And since each of these new x values goes to only one y value, we'll say yes, f inverse is a function. And since both the original and the inverse are both functions, then we would say that the original is also considered to be one-to-one. So f is also a one-to-one function. Now, looking ahead then at some graphs, let's recall that if we are looking at the graph of a collection of ordered pairs, we can use the vertical line test to say, yeah, this is a function. So yes, f is a function because it passes the vertical line test. Now, in order to determine whether or not f is one-to-one, we would need to find the graph of the inverse and determine whether or not the inverse is also a function. And in order to determine the inverse, basically, again, we're just going to switch the x and the y values. And so here on this graph, we have the ordered pairs 2, 0, negative 2, 0. We also have an ordered pair 0, negative 4. So on my inverse, we're just going to plot those ordered pairs. So 2, 0 corresponds to the ordered pair 0, 2 on the inverse. Just switch the x and y. Negative 2, 0 corresponds to the ordered pair 0, negative 2, just switching the x and the y. 0, negative 4 corresponds to negative 4, 0. And then essentially what we'll see here is that after we switch all the x and y's on all of the ordered pairs, I've just shown 3 of them, but once we switch them all, we could connect those dots and see that we end up with a sideways parabola, which if we apply the vertical line test to, is not going to be a function, and therefore the original must not have been 1-to-1. Just as a quick reminder, I oftentimes use 3 dots in a triangle, which is a math symbol that represents therefore. So we can say then, therefore, f at x, the original, was not a 1-to-1 function. It was a function, but it's not a 1-to-1 function because its inverse is not a function.